The learning objective for this lesson is to balance chemical equations. This is a fundamental skill that we're going to need moving forward in Year 10 chemistry. Now, one of the molecules we haven't looked at yet is diatomic molecules. Now, they are really simply a molecule composed of only two atoms of the same chemical element. So things like O2, H2. You can kind of think of them like the Siamese twins of molecules. There's a really simple mnemonic I use to remember which elements will form diatomic molecules, and that mnemonic is "have no fear of ice cold beer." So all of those letters at the start of that mnemonic are allocated to hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, bromine. All of those elements will form diatomic molecules. Now, the whole concept of balancing equations is based on this fundamental physics law called the conservation of matter, where matter cannot be created or destroyed, we can only change its form. So as far as we're concerned, it's this first statement here that matter cannot be created or destroyed. So we need to have a balanced amount of elements and matter in the scenarios that we're going to be looking at. So when we look at chemical equations, when we use a subscript, which we've already used subscripts before, they indicate the number of atoms of the previous element in the molecule. So for instance, H2O, the 2 indicates the number of H's, so 2 hydrogens. So this molecule looks like this. It's got 2 hydrogens and 1 oxygen. Should be straightforward at this point now. If we put a large number in front of the molecule, it indicates the amount of molecules. So you can kind of imagine this as if we had a bracket around the whole molecule. So 2H2O means that we have 2 of these molecules. So in this case, if I wrote 2H2O, there are now 4 hydrogen and 2 oxygen. A balanced chemical equation must have the same amount and type of each atom on both sides of the equation. This is based off this law we looked at a second ago, the conservation of matter. So in a chemical equation, you can only change the large number out the front, not the subscripts. Let's work through some examples and you'll see why that's the case. So we're looking at this equation where we have oxygen plus hydrogen to give us water, H2O. Now, oxygen and hydrogen are both diatomic molecules, so we write them as O2 and H2. Now, the formula for water is H2O. That can't change. If we change this to something different like H2O2, it's hydrogen peroxide. If we change it to HO, it's then hydroxide. So it must be H2O. We can't change what the molecules are. All we can do is change the amount of molecules. So let's draw this diagrammatically now. You can see I've drawn in the atoms for each molecule. Now, what I want to do is try and balance the amount of atoms on each side. I can see that I've got 2 oxygens on the left side and 1 oxygen on the right side. So that doesn't balance, so I need to make more oxygens on the right side. So I'm going to put a 2 out the front of the H2O, and that gives me now 2 water molecules. Problem is now, if I look at how many hydrogens are on the left and the right, I'll see that they're now unbalanced. So with the hydrogen on the left, I have 2 hydrogen atoms. If I look at them on the right, there are 4 hydrogen atoms. So that's still no good. So now I'm going to add a 2 in front of the H2 so that I have 2 sets of H2 molecules. So now if I look at how many hydrogen atoms there are on the right and left, they both have 4. This is now a balanced chemical equation. Let's do another one, but it's not going to have the diagrams, but I'll show you the process which I'm using. So I'm adding nitrogen and hydrogen to give me NH3. I'm going to start with the nitrogens, and I'm going to count how many are on the left and then on the right. So on the left, I have 2 nitrogens based on that little N2. On the right, I have just 1. So I can see straight away that my nitrogens are not balanced. So I'm going to double the amount of NH3s. So I'm going to put a 2 out the front, and now that's going to change my amount of nitrogens on the right to 2. And on the left is 2, so now those are balanced. Now I'm going to have a look at what's happened to my H's. So on the left, I have 2 H's, 2 hydrogens, and on the right, I have 6. Now I have 6 because in the molecule NH3, there are 3 hydrogens, but I have 2 of those molecules. So that's 2 times 3 gives me 6. So I now need to do something to the left side, those H2s, so that I have 6 hydrogens so that they can be balanced. So I'm going to times the H2s by 3, and then that'll give me 6 H's on the right and the left. That's very simply how we balance chemical equations. All you've got to do is start working through the different atoms, working right to left, and making sure that they're all balanced and equal on each side. Have a crack through these questions, and make sure you discuss with your teachers if you have any difficulties with this.